So as we've talked about data types predominantly focusing on like characters and integers, right? And so these are really just some number of bytes in memory that store some value. Like what the value's meaning has is up to the programmer, whether it's just an integer, if it's actually in the case of like a char, if it's actually an ASCII character, or whether it's actually just an 8-bit value. This is up to the programmer to sort of decide, right? But everything is every value, every data type or value is just some sort of human readable identifier that references a chunk of memory. What is in memory is up to you, the programmer, and the compiler. Like the compiler can do some checking. Like for instance, it can say, okay, this function's meant to return an integer, but he's storing the value in a char. There might be some problems here. But the compiler can't really do advanced checking when it comes to the length of arrays that are dynamically allocated, that you don't go too far in memory. It can't, for instance, do stuff with like custom data type structures that you've created. There are its limitations. So that like a lot of errors in C come from when the user has done something wrong and the compiler just can't pick it up, because the code's not really wrong, but the user has somehow just used memory in a bad way, right? So this is also the advantage of C, is that we can just go and do whatever we want with memory. I mean, we're not limited by the constructs of some sort of super type language that does lots of checking and whatever. It just lets you really do whatever you want. So it comes with a great risk, but it also has a great reward. So sometimes we'll need to keep track of what is stored in memory, how large it is, like how it's structured, what we need to do to access it, blah, 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 right? And so when we can sort of talk about this, we're talking about arrays. This is like where I would start talking about this, because arrays can be a fixed length, but they can also vary in length. So when we're talking about the stack and the heap, if you create an array statically, like you declare at the top of your function, int blah, 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 my array, and you do little brackets, which we'll see here is how you define the size, the compiler knows the length of this array. So the compiler there is a bit smart. It can probably tell you, hey man, if you define an array of length 12, you can't go and access the 20th element. That doesn't work. That is, you're accessing invalid memory. But if, for instance, you're doing some sort of dynamic program that needs to create arrays that suit a size that can change, like you're breeding in some network packet, and the packet needs an array to store the buffer, and the buffer is constantly changing in length, then the compiler has no idea when it compiles the program how long this array is going to be, and therefore it really can't check much stuff, right? So it's up to the user then to sort of make sure that they keep somewhere in another variable the length of the array, and make sure they never go outside of, or they try and access outside of that array, right? Because otherwise you'll get memory errors. So arrays on like a fundamental basis have a data type, but the data type is of each individual element. So an integer array is an array of integers. So it's just lots of integers stored continuously in memory. So if I have an array of 4 integers, it'll be 16 bytes, because it's going to be 4 bytes for the first integer, 4 bytes for the second integer, third integer, fourth integer, stored sequentially in memory. So we can just go and obviously access the memory location because it's C and it'll let us do this. But how you generally access arrays is using an index, because the C programming language gives you a way to declare and to access arrays. So the declaration is the type. Some array name, so this is the variable name, what we identify, so my array or buffer or what have you, whatever you want to call it, and then the size. So this is telling us, the type is telling us how big each element is. If we do size of int, it'll say, yep, okay, each element is 4 bytes. And this is telling us how many elements we have. So the total size is the size of the type times by the array size. And then just simply, as we declared it using the square brackets, we also use square brackets to access the individual element. So to access the second element, the second actual in memory, we would use the first index, because the first index is 0. So we'd go array name 1 to get the actual second object in memory, because it starts counting, like indexes in C start at 0. Unlike MATLAB, because MATLAB's stupid. So then we'll talk about like a little example. So arrays can be initialized with values or zeroed out. So I tried to show an example, but I got really lucky in that the memory that I was using in my example was already zeroed out. But if you don't initialize array with value, it can just have random junk in it from memory. Because memory that's not being used is not necessarily zero or has some fixed value. It can just be completely random. And so if you don't initialize or zero out an array when you create it, you cannot guarantee that there will be a zero in it, right? You can't assume that it's going to be zero. And so we'll see here in our little example, what we're doing is we're creating an integer array of length 20 called myIntArray. And we're using this notation here, this squiggly bracket 0, and what this notation does is it says set every single item to 0. So essentially the 40 bytes that we need for 80 bytes that we need to create this array will all be set to 0 in memory. So if we went to run this code and debug it and we printed out the value of all of those memory locations, they'd all be 0. And so then we can access, or in this case we're accessing the first element to write to it. So we're setting its value equal to 1. Just as we are here setting now the 19th value. So this is the last value because it's 20 length, so 0, 1, 2, 3, 4, up to 19 are the indices. And we're now setting the 19th value equal to the first value. And so this is what we're using it to access it, same notation, and same notation here to write into it, right? So this is zeroing out the array, but if we wanted to actually give the array values, we can use this notation here. And so for instance, now we're creating a double array. So a double is a floating point value, so it's a decimal. We've called it myDoubles, and we've given a length of 5, and here we are giving it essentially its initial values. And so if you looked at this after this is created in memory, these double values will be sitting in memory sequentially. I think a double is like 8 bytes or something. So in 40 bytes, depending on your system, of course, I don't know this off the top of my head. So now a further example. So what this notation is doing, because memory is all these variables are stored sequentially in memory in C, this notation is pretty much just saying to us, hey, from this memory location at the beginning of the array, we know the data size of each element. Just go that size times the index into memory and return to me what you find there, right? And so you can do this manually. You can, as we'll see in this example in a second, just go, hey, this is where my array starts. I'll just take the value this many bytes ahead in memory and return it, and then we're good. But it's tricky, and so mainly because of memory alignment and whatnot. So this is sort of an advanced topic that you probably won't even see in your complete studies, but the square bracket notation is much simpler. It's just saying, hey, okay, cool, we know the size of the array, like the size of the array type, each individual element, and we'll just step through memory that many times and return what we find there. And so that's what's happening here. We're saying, okay, cool, we're creating a zeroed out integer array of length 20. We're setting the sixth element to 1. And this is the same as saying, okay, cool, this here is the address of my array, and we're just going to move 5 ahead. And why I'm doing this and not 5 times the size of my integer, and this is where it gets tricky, is because of the alignment of the array. I can only, one step in memory is one 32-bit step, and therefore I only actually, if I was to do 5 times size of int, I'd be moving 20 times 4, 80 bytes in memory, and this is well outside of what I want, but this is the same thing. And so in the future, when you'll learn lots more about C, you can come back to this and it will make sense. So when do we use arrays? Pretty much the most predominant or the most common use of arrays is strings. Now C doesn't actually have strings. In Python, for instance, you have the stir object, and it is actually like an object where you can You can set its value, you can convert it to an integer, you can get its length by using the .leng object method. Like it's an actual data type with lots of methods and functionalities. But C doesn't have these sort of inbuilt data types and complex objects that you have like in Python. And so C uses strings, but they're not strings as you would know them from other languages. What a string is in C is simply an array of characters. And as we've seen from the other examples, a character is some ASCII code, some value between 0 and 255 that represents a character, like an ASCII character. And so a string is just a collection of these sequentially in memory, and we put a termination character at the end of it so that we know when the string ends. Because essentially every byte in memory has some value between 0 and 255. So how are we going to know if it's the end of the string? There is no ASCII character for 0, so we can be sure that the string is never going to include 0 as an actual character. And so therefore we put this 0 at the end of it. And this helps because when functions that use strings as an input, all they have to do is they take the beginning of the string in memory and they just keep stepping through memory until they find this termination character. And then it's when they say, okay, cool, that's the end of the string, done, right? And so it really helps to iterate through the string without necessarily knowing its length. And so this is a predominant, like a really common use of arrays. And to sort of declare a string, there are two sort of different ways. So either you declare literally a character array here, and you're saying, okay, cool, I want to have a character array, and if we sort of got rid of this hello world, you would just have a character array of length 12. But if we put this hello world in here, this is essentially saying, I want to initialize this array to have this contents. Whereas the second one is saying, I don't know how long this array needs to be to store this initialization value. And so the compiler will go ahead and figure this out, and will end up creating the same thing in both cases. But the good thing is that if you do the second one, you don't have to sit there after you've typed in some long string that you want to store in some array and actually count the characters, because the compiler does this for you. This is super simple, right? So we'll look at an example from a string. Here on this first one, we're creating a character array. Now, I would not call this is not a string. And why it's not a string is because this is of length 5, and I have stored in each individual element a character. But the thing that turns a char array into a string in C is this termination character. Now, I haven't added it here. As you would see in the previous slide, if we count hello world is 1, 2, 3, 4, 5 space. So there's 6, 7, 8, 9, 10, 11 ASCII characters. But we need to set the length of the array to 12 because we need to have space for this termination character. You need to include this. And this here, the second line, will automatically do this. They will both declare char arrays of length 12 to account for the termination character. But what I have done here is I have explicitly created a char array of length 5 that doesn't include this termination character. So you can think about it in memory. If I was to then pass this character array to some function that uses the string, it won't know when to stop. It will keep stepping through memory until it finds a 0 value, which will exist probably in memory somewhere. But you're going to be reading lots of invalid memory, and you're going to be corrupting and breaking your program. Your program is not working as it should, or as any program should. So then this first one here is a character array, but I wouldn't call it a string necessarily because it lacks the termination character. The second one, on the other hand, is though. And so you can see here, I've got hello. Here I have space world, because the space is also an ASCII character. It has a value. And then this initialization here, because I don't have a length in here, will actually add in the termination character. So this is going to return to me a string of a character array of length 1, 2, 3, 4, 5, 6, 7. And what I can do here with print, I'm printing both of them. So I'm passing in this first one as a string. And here I can do this because it will substitute it in here, and then they will substitute the second one in here, and I'm relying on this second one having the termination character. So this here is essentially just a character array with what I wouldn't really call a string, but by putting them both together, I've sort of just taken a character array and made it part of a longer string because the second one has a termination character. And so if I do this, I will actually get a hello world output. So I'll do a quick example on this now.